Okay, perfect. So we've done shift and translations, and we've done stretch. Now the important thing to note is that if the transformation is happening in the x direction, in other words, you're changing the value of x, okay, it's the opposite of what you think it should be. We've established that. So if there's a shift in the x direction, it's the opposite direction to what you think it should be. And if there's a stretch in the x direction, it's the opposite of what you think it should be. So in other words, you thought it was going to be a scale factor of b, instead it's a scale factor of 1 over b. Whereas if it's changing the y direction, well, okay, you do the function first, then you change the value, okay? So it behaves, okay? So if you're shifting it upwards by a, or stretching the y direction by a scale factor of b. So really what I want you to take away here is that if it's a shift or a translation, you're basically adding or subtracting, okay? So adding or subtracting corresponds to a shift or a translation. A stretching corresponds to a multiply or a divide, okay? All right, fantastic. Now there's one final transformation that we need to look at. I wonder if you can think, what are we missing? So we've got this idea that we can shift the graph around, either left or right, up and down, or combinations of them. We've got the idea that we can stretch the graph, so literally grab it and pull it upwards or downwards, or pull it outwards or inwards. What are we missing? Absolutely. It's a reflection, that's the one we're missing. So we literally change the direction of the graph. Okay, so reflection, if you want to call it a flip, fine. I would encourage you to call it a reflection though, okay? So let's look. Well, effectively what's happening with a reflection, so for example, if I want to reflect it in the x-axis, okay? What will effectively be happening is I say, well, okay, whatever my x value is, find the corresponding y and then just make it negative. Does that make sense? So in other words, all of the y values have to become negative in order to reflect it in that x-axis. So if I take my output value, so f of x, those are my y values, aren't they? Those are my output values, those are my y values. So if I want to reflect it in the x-axis, I just need to make them negative. Yeah, so whatever my output values are, make it negative, output value, negative, output value, negative, output value, negative. So in other words, all of these output values will end up down here instead, in the negative region. So okay, let's see that. So in this case, my function is x squared, and I'm just saying, make my output negative, okay? So if I put 0 into my function, what do I get out? 0. Perfect, because negative of 0 is just obviously 0. If I put 1 into my function, what do I get out? Perfect. If I put 2 into my function, and 3? Perfect. What about negative? So I put negative 1 in there.
1.
Not 1. Put negative in that, I get negative 1 all squared, which is 1, make it negative. Perfect. Okay, now that's exactly what I wanted, look. Because the 9 becomes negative 9, the 4 becomes negative 4, the 1 becomes negative 1, the 1 becomes negative 1, the 4 becomes negative 4, and then the 9 becomes negative 9. So that literally just means that I take this graph here, still going through the origin, so still the vertex at the origin, okay, but I just basically flip it upside down, so flip it in the x-axis. And that's literally what I'm going to write there. So this is going to be a reflection in the x-axis. Oops, does that make sense? Yeah, so it's a reflection in the x-axis. Okay, well, if that's a reflection in the x-axis, so in other words, you make all of your output values negative, you change the output values, what do you think a reflection in the y-axis is going to be? How can I change this? Where am I going to put the negative now? Good. I make the x negative, so in other words, I make my input negative, then apply it through my function. So in this case, I get negative x, and I square it. Okay, let's see. Put 0 into my function, what do I get? Put 1 in my function, what do I get? So, yeah, negative 1, all squared, so that's going to be 1. 2 in my function. And then, what about if I put negative 1 in there? Good, because it's the negative of negative 1, which is obviously 1. Square it, I get 1. What if I put negative 2 in there? 4, and then negative 3? 9, perfect. So what's happened in this case? Still a reflection, but which axis has been reflected in? It's going to be the y-axis, isn't it? Yeah. Now the reason why these values haven't changed from our original graph is because if you think, if I reflect this graph in the y-axis, are you happy because this is symmetrical, I'll just get exactly the same graph back in this particular case. So it has been reflected, it's just because it's symmetrical, you don't see that reflection happening. So in other words, the vertex is still down here at 0, 0, okay? But there has been a reflection which has happened. Like these values here, so if I call that like set A, these values here have ended up over here, okay? And these values here, so if I call that set B, have ended up over here. Okay, so they have been reflected, it's just that because my function was symmetric to start off with, that actually I don't see that happening. Okay? So, let's generalize it then. All right, so if I take, so let's do my reflection in the x-axis first, which was this one here. So if I do negative of my function, so I apply my values to my function, then make them negative, that will be a reflection in the x-axis. In the x-axis, okay? So as an example, you apply your x squared first, you put your functions through the squaring function, then you make it negative, okay? Whereas if you swap the order of the negative, if you make your input values negative, and then apply your function, that's going to be a reflection in the y-axis. So reflection in the y-axis. Okay, y-axis. So as an example, you make your input values negative, then you square it. Okay. Now, just so happened that that particular case, y equals x squared, because it was a symmetric function to start off with, you didn't notice the difference. But in general, that will always be the case. So, in other words, and I'll give you a second to write this write this thing down, then we're in a position we can finish off. Okay. This is the thing you need to remember. Okay. So this is dealing with negatives, I should write. This is the thing which you need to remember. So I'll let you write it down, then I'll go through it. Done it? Okay, fine. So there's three different functions that you need to remember, okay? Well, there's three different transformations you need to remember. You need to remember shift, stretch, and a reflection, okay? A shift is always corresponding to adding or subtracting the values, okay? A stretch is always corresponding to multiplying or dividing the values, and a flip or reflection is always just making those values negative. Okay, so if you see negative of something going on, it means it's a reflection. If you see a value being multiplied or divided, it's always a stretch. And if you see your value being added or subtracted, then that corresponds to a shift or a translation. The thing to note is that if you're working with a shift or a translation, or a stretch in the x direction, it's the opposite of what you think it should be. Okay, so if you see like you're changing the x by adding on some value, you think it should be moving to the right by that value. It's not, it's moving to the left. Okay. Likewise, you see that your x value is being multiplied by a value, you think, okay, that's happening in the x direction. However, it's not being stretched outwards by that many values, it's being stretched inwards, hence it's the 1 over b business. Okay. If it's happening in the y direction, that's all good, okay? Oh, that's all good, not bad. Okay, that's all good, okay? That's all fine. So if you see it's the function first, so you're changing the y values by adding or subtracting some value, that's fine. It's moving upwards by whatever that value is. Likewise, if you see that you're changing your function values, your output values, by just multiplying by some value, that does correspond to a stretch being pulled upwards, okay? Whatever you see what's going on there. And the reflections, personally, the way which I remember the reflections, the negative in this case comes first. Well, what comes first in the alphabet? Well, x comes first. So remember, that's a reflection in the x-axis. If you wanted to remember it logically, it's just literally saying, take your output values, make them negative. Well, your output values are your y. If you make the output values negative, it's got to be a reflection in the x-axis. This one though, well, the negative comes next, that's coming first, that's coming next, therefore it's a reflection in the y-axis. And likewise, all you're just literally doing there, you're just taking all of those x values and flipping them over and making them negative, so the negative or positive of what they were before, so therefore it's a reflection in the y-axis. Is that okay? Are there any questions? So I appreciate that's kind of like quite a lot of theory, but ultimately what it means is that you can just remember that table and just remember the features of that table and how it all fits together, and transformations of graphs should be really easy. Yeah, if you just remember that table.